right, so I want you to, it's a pulley system. I've got a frictionless pulley. M1 is bigger than M2, more massive than M2. I want you to find the acceleration of M1. However, your answer must be in terms of M1, M2, and any fundamental constants. Which means acceleration can't appear in your answer for acceleration. I saw that earlier today. And tension can't be in your answer for acceleration. Just M1, M2, and any fundamental constants. Give it a shot. Let's see if you are successful. Well, I don't have to check everybody to know if you reach 70%, right? So they might be contributing to the 70% or not. I don't know that. But you reached the threshold. So should I go check them to ensure which side of the 70% they're on?
I think you should.
I can always count on seventh period to get the right answer. I just assume for the most part it's because everybody else told you what we're doing today and you're all cheaters. But let's assume that that's not true. Good job, everybody, doing this part. I'm glad to see that. You all made a conscious decision about direction, setting this side positive and this side positive. That's not really worth a point, but what I do want to go through and talk about, there are some mistakes that will lose you points if we're talking about how your FRQ might be graded. Does that make sense? So I want to hit that real quick. Did you ask yourself the whole question about if this one goes up 10 centimeters, does this one go down 10 centimeters? Reasonable question about seeing if the accelerations are the same, and in this case, there's every reason to believe they are. Free body diagrams are a mess, and if you want to know how you're going to be graded, we'll consider this. There should be a downward arrow indicating M1G. There should be a downward arrow indicating M2G, but this one should be smaller than M1G because we have defined it that way. The only way M1 accelerates downwards is if tension is less than the weight. But the only way M2 accelerates upwards is if tension is greater than the weight. However, with a massless pulley, I said frictionless, but I meant massless as well. But I said all pulleys this semester would be massless. With a massless pulley, the tensions would have to be the same size. Remember, the next test you have, the place where you'll do your free body diagram will have a grid on it to ensure that you can make these kinds of adjustments. Net force equals MA. So T minus M2G equals M2A. A mistake I've seen on a bunch is forgetting that we're dealing with mass 2 here, so the mass that you put here is M2. Saw that in a couple of papers. A few of you corrected yourself, a few of you required correction. M1G minus T equals M1A. I'm thankful that you guys appear to be able to do basic algebra, maybe even advanced algebra. But I was happy to see that because that has not been the rule today. Meaning I have a lot of students who could get here and then that's where it ended. You have lots of opportunities to get rid of T, a lot of ways to do so. Are you asking a question, Owen? You had your hands like you're doing this. I don't know where the division is. No worries. You know how I want to do it, but there's other ways. Thankfully, this room isn't really an issue, but let me just remind you, substitution works. You could solve this one for T and plug it in over here. That'll get rid of T. You could solve this one for T and this one for T and set those two things equal to each other. But you know that I like this idea that if you set your problem up the way I've been setting them up, you will get two relationships where the T's are additive inverses. So when you add them up, they will cancel out and you'll be left with M1G minus M2G equals M1A plus M2A. Now, yes, there is some algebra here. This class did a great job of breezing through it, but not really sure if they were doing it right, but yes, you are. Factor out the A. I did have a few of you who had A in your answer and had to go back and figure out how to get the A out or not. But yes, we get every term with A on one side, factor the A's out, and then divide by whatever's in front of A. I want you to consider that you could also factor the G's out. And you get something that looks like this. Now, the reason why I want to write it like this is not because I think this is a better way of writing your answer. In fact, I want to point out that when you were here, you had net force equals mass of system times A. That always has to show up. There will always be a part in these multi-body problems where the mass of the system, the sum of all the masses, is going to show up. I want to get to this because first, this term is unitless, right? Kilograms divided by kilograms cancels out, so there's no units inside there. That means whatever the units of G will be the units of A. G is an acceleration, so you have a way of kind of checking and ensuring that your algebra is done correctly. But also, it occurs to me that everything in here is measurable. Meaning if I just have a couple of masses laying on a desk, I could hang them on either side of a pulley and it would be a measurable thing. I could measure the mass of one, the mass of the other. And over here, I think this is measurable. We know several ways, We know several ways to measure acceleration, motion sensors, timing it, stuff like that. This, however, would be independent. I could pick specific masses. This would be dependent. I would only be able to measure the resulting acceleration. Are you following me? So I'm thinking, if I have the right data set, something that looks like this, I could plot this data, plotting this on the y-axis and this on the x-axis. And it should be linear, and the slope should be g. This is a way of measuring the acceleration of gravity. Not a great method. It gives good values for g, but I'm about to show you why it's not a great method. But this is what I'm looking for. So let's talk